Have you ever just stopped and wondered how the internet feels so, well, instant? I mean, how does a little box, like a router, manage to juggle millions of data packets every single second without even blinking? Well, today we're going to pull back the curtain on a piece of networking magic that makes it all possible. Right, this is the big question. A router is basically a digital traffic cop, and its entire job is to get every packet where it needs to go, like right now. If it had to stop and think about every single car or packet, our networks would just grind to a halt. So what's the trick? How does it keep up that incredible pace? And here it is. This is the secret sauce. You see, the most efficient systems out there don't solve the same problem over and over again. Nope. They do all the heavy lifting up front. They figure out the answers before the questions are even asked. And this idea, this principle of pre-calculation, is what unlocks unbelievable network speeds. Now, to really appreciate just how brilliant this solution is, we first have to understand the problem it was designed to solve. So let's take a quick look at the major performance bottleneck that used to plague older routers. Okay, imagine the router's main brain, its CPU, as just one single traffic cop standing at a ridiculously massive intersection. In the old days, that poor cop had to personally inspect every single car, check its license plate, look up its destination on a huge map, and then tell it which way to go. You can see the problem, right? With the amount of traffic we have today, that's a recipe for a total standstill, a massive traffic jam. So the solution that came along is a system called Cisco Express Forwarding, or CEF for short. And at the heart of CEF is this brilliant partnership, a dynamic duo that just splits up the work to solve that speed problem once and for all. It's genius, really. The system breaks the job into two distinct parts. First up, you've got the forwarding information base, or the FIB. Think of the FIB as your GPS map. It gives you the big picture, telling the router the general direction, the next town or the next highway exit to take. And then you have its partner, the adjacency table. This is more like your prepaid toll pass. It has the exact information you need to get through the very next gate, no questions asked. One tells you where to go, the other tells you exactly how to get there. And that second part, the how, that's what we're really going to focus on today. Let's zoom in on the star of our show, the adjacency table, and see precisely how it pre-calculates its way to just incredible efficiency. So what is this thing really? Well, the adjacency table is basically a database. It stores all the ready-to-go forwarding info for every single device the router is directly connected to. And the key word here, the most important word, is pre-compiled. This information isn't being made up on the fly. It's all prepared and waiting before it's even needed. So, what kind of info are we talking about? Well, if you look inside a single entry in this table, you'll see it has everything the router needs. It's got the IP address of the next device, its physical hardware address, that's the MAC address, the exact port on our router it needs to leave from, and, this is the big one, the complete finished Layer 2 header, all ready to be stamped onto the packet. The best way to think about it is like having a pre-baked pizza crust. When an order comes in, the chef doesn't have to make the dough from scratch every single time, right? No way! They just grab a pre-made base, throw the toppings on, and it's out the door. That same efficiency is what lets the router forward packets at wire speed, literally as fast as the physical connection can handle. The system is also pretty smart. It has different types of entries for different situations. A normal adjacency is what you want to see. It means everything's good to go. A glean adjacency, though, that's kind of like a placeholder. It tells the router, hey, I need to figure out the hardware address for this neighbor. And that triggers a little process called an ARP request, where the router basically shouts out, hey, who has this IP address? Punt is for really special cases that need the main CPU's help. And drop, well, that's exactly what it sounds like. It's a dead end. All right, theory is great and all, but let's get our hands dirty. How can we actually peek under the hood and see this table for ourselves? On a Cisco device, the command you're going to use is show adjacency detail. Think of this command as our special magnifying glass. It lets us look at the raw, pre-compiled data where all the magic happens. Okay, so when you run that command, you're going to see a long string of letters and numbers that looks something like this. And I know, at first glance, it just looks like a bunch of gibberish. But this is it. This is that pre-calculated header we've been talking about, just sitting there waiting for a packet. So let's decode it together. It's actually pretty simple. The first chunk of characters, that's the hardware address of the next router, our destination. The second chunk, that's the hardware address of our router's outgoing port, the source. And that little bit at the end, 0800, that's just a code that tells the network, hey, the data inside this thing is an IPv4 packet. All 3 parts, pre-assembled, ready to go, absolutely no thinking required at send time. So why does all this technical stuff matter? I mean, really, who cares? Well, you care when things go wrong, because understanding how it's supposed to work is the absolute key to figuring out what's happening when it breaks. For example, if a network admin sees an entry that's just stuck in that glean state we talked about, that's a huge clue that the router can't find its neighbor for some reason. Even worse, if an adjacency for a busy destination is just gone, the router might have to fall back to that old, slow method of using the main CPU for everything. And when that happens, you see the CPU usage spike and network performance just tanks. So, what's the bottom line here? It's that the adjacency table isn't just some obscure technical detail. It's a direct indicator of your network's health. When it's populated correctly and everything is normal, data just flows. When it's not, you get slowdowns, bottlenecks, and traffic jams. It's truly the silent hero of high-speed networking. You know, this whole idea of pre-calculation was a revolutionary step forward. It solved the major speed problem of its day. And that leaves us with one last thought to chew on. What are the bottlenecks of today? And what clever new trick is network hardware gonna have to learn to solve the speed problems of tomorrow? Thanks for watching.